Hello everybody, today we are going to present about equatorial coordinate system with Napath and Mattaya. So this is our DIY celestial sphere. So celestial sphere is an imaginary sphere around us, like in the sky. So our celestial sphere model have a green line to depict as celestial equator. This is an imaginary circle on the celestial sphere aligned with an Earth's equators. And then we have a red line to depict as a ecliptic, which is the part of the sun across the sky. So first of all, I want to introduce you guys to the 4 day, uh, which including summer solstice, vernal equinox, winter solstice, and autumnal equinox. So I would like to start with the summer solstice. So the name of the solstice, I will rely on the northern hemisphere. So on the 21 June, the sun would located higher than the earth, which make the north hemisphere have longer day than the night. Then the land would absorb more heat, which resulted in the season that called summer, and which contradict to the south hemisphere. So the south hemisphere it would have a short day and long night, which resulted in the season called winter. So the sun is located higher into the northern hemisphere. So the position of the rising position of the sun would be also near to the north direction, as you can see in the right pictures. And in the right picture is also show that the sun part on June 21 it would have more long day duration than the southern part. And for autumnal equinox and vernal equinox is the middle position between summer solstice and winter solstice. So vernal equinox it will be around 20 March, and autumnal equinox it will be approximately 22 September. So at this position, the sun would be at the same level to the earth. So the north hemisphere and south hemisphere it would have the duration of the night equal to day. And from the picture at the right side, so now the sun is at the same level to the earth. So the sun part, it would be at it would rise at the middle of the north direction and south direction, or directly rising at the east direction and set at the west direction. And the last day is winter solstice. So the winter solstice would be around 21 December. So it caused the north hemisphere to have short day and longer night. So which contradict to the south hemisphere would have the short night and long day. So right now the north hemisphere it would have the winter season, and south hemisphere it would have summer season. And you can so now the sun is located below the earth. So the position of the sunset is near to the south direction, and the sun part in the picture is also shorter than the sun part. The sun part in north hemisphere the sun part in north hemisphere is also shorter than the sun part in south hemisphere in the picture. Yeah. And for equatorial coordinate system, it is a system to tell the position of the star in our sorry, what is called again? In the celestial sphere. So it has two variables that called right ascension and declination. So the declination is a variable that are used to tell the position in vertical side. So it will start from 90 degree to minus 90 degree. And for the right ascension, so for declination, it have the reference plane as the celestial equator. So that position is 0 degree. And for another variable is right ascension. So right ascension it have reference point at vernal equinox. So it's the position that the line of ecliptic cross with celestial equator. So it would be around 20 March, and at this point, the right ascension it will call 0 hour, and then uh the position it would divide into 24 part as how they have 24 hours. So for example, the star in this picture is located at 22 hour of right ascension and positive 45 degree of declination.
Okay, so as Mook has explained about the equatorial coordinate system, it is a system that is like there's a big map of the sky, which is the celestial sphere, that doesn't change no matter where we are on Earth. But when we have to see the stars on Earth, we need to use the system that's based on where we are standing on Earth, and this system is horizontal coordinate system. And the question is, if we know the declination in equatorial coordinate system, how to identify coordinate of the star in horizontal coordinate system? As we know that in equatorial coordinate system, the celestial equator is used to be reference plane that makes the north celestial pole perpendicular to the reference plane. And as you can see in the first example, when an observer is at a latitude of 0 degree north. Okay, so when the north celestial pole has declination as positive 90 degree, that makes the declination start above our head. And I mentioned Polaris because the declination of Polaris is around positive 89 degree. That quite close to the NCPs. So that means Polaris is located really close to the NCP, and it can be used to like be a reference star to find other stars, because it is easy to spot in the sky. And next example is at a latitude of 13 degree north, which is at Wangzhen, Rayong. As you can see that the NCP is now about 13 degree from the north, so the declination gonna start at around 13 degree from our head to the south, as it's perpendicular to the NCP. And now we proceed to the last topic, circumpolar stars. How to find circumpolar star in horizontal coordinate system. So first, there's the circumpolar stars, other star that never set below the horizon. From a specific location, they appear to move around the NCP or SCP and remain visible all night. In the northern hemisphere, circumpolar stars have declination more than 90 degrees minus latitude. On the other hand, in the southern hemisphere, circumpolar stars have declination less than minus 90 degrees plus latitude. Okay, so let's see the example. At Wangzhenderong again, the latitude of 13 degree north, as it is in the northern hemisphere, so since 19 minus 13 is equal to 77, so the star with a declination more than 77 degrees will be circumpolar star. And this is the end of our assignment 3. Our DIY is Theosphere. Thank you for watching.